All right, so this is a quick video preview of where we're headed after the break. And the first topic we're going to encounter is inclined planes. So I just want to kind of explain how inclined planes are different than what we've done before, as well as how they are similar to what we've already done. So in the interest of doing so, up to this point, we have looked at objects, often boxes, sliding across the ground. Maybe we put an applied force on it and we drag a box across a flat surface, a horizontal surface. And when that's the case, we have a normal force that acts upwards, we have a gravitational force that acts straight down, and we often have a friction force that opposes the motion. And we orient our coordinate system such that x is across the horizontal surface and y is vertical. So normal forces and gravity act in the vertical direction, and often the applied forces, if they're not at an angle, act horizontally or in the x direction. Now, when we shift to inclined planes, what we do is we take this horizontal surface and we tilt it up so that we get a surface that's on an angle. And when we do that, we take a lot of things with us. And by that, I mean the normal force. If you remember, the definition of normal in engineering terms is perpendicular. So that force is always perpendicular to the surface. When I tilt my surface by some angle theta, this normal force goes with us. Instead of being straight up, which is perpendicular to horizontal, now it remains perpendicular to our surface. So essentially our normal force rotates with the surface. So the normal force will still be perpendicular to the surface that we're sliding on. The friction force, which was parallel to the surface, so they were both horizontal. If something slides horizontally, the friction force is horizontal. The friction force here remains parallel to the surface. So the friction force and the normal force come with us when we tilt our surface. The thing that doesn't come with us is the gravitational force. The gravitational force is still straight down. The direction of the force of gravity does not change just because we tilt our surface a bit. What we were going to see on the next slide is that in order to analyze these situations, we want to make sure that we bring our coordinate system with us as well. In other words, when we had a flat surface, our coordinate system was such that x was along the surface or parallel to the surface, and y was perpendicular to the surface. It was up and down. So normal forces and gravity acted directly in the y direction, and often our applied force and friction forces acted in the x direction. We still want our y axis to be perpendicular to our surface, so we tilt that along with the surface here. And we want our x direction to be parallel to the surface because the box is going to slide along the surface. So we want to be able to analyze forces in the direction of motion. So we want to analyze forces in this x direction. So we make sure that the x direction corresponds with the direction of motion here, which is along the surface. What that does for us, it poses a small problem. I mean, it's convenient. The normal force is still vertical. The friction force, or it's by vertical, I mean in the y direction here. And the friction force is in the x direction, but now gravity is at a funny angle. The force due to gravity is no longer in the y direction. The force due to gravity is at an angle, and I'll show this in the next slide, we have to break it into components. So the force of gravity now doesn't act along any particular axis. It acts along both. Some component of the force of gravity pushes the box into this surface, and some portion of the force of gravity is trying to pull the box down the surface. That's why things slide down inclines, because the components of gravity hold it against the incline and pull it down the incline. So we have to be able to break, and this isn't a new thing, we did this with diagonal forces on flat surfaces. We have to be able to break any forces that are not in the direction of our axes into components. And in this case, gravity becomes one of those forces that is no longer in the direction of the x or y axis. So to break gravity into its components, it's pretty easy to show that if we tilt this plane by some angle theta, that we are moving the force of gravity in the y direction, because the y axis tilted the same amount, right? The xy axis was flat before, and then we tilt everything by some angle. So now the xy axis has rotated by that angle. So if we rotate our y axis by some angle theta, then our y component is going to be theta away from the vertical. So anyway, all that is just to say that simple trig is what we use to find the components of gravity. So when we analyze our system, the x and y direction, we look at the y direction, which is perpendicular to this surface, and we see that that's the adjacent side to the angle. So the y component is Fg, force gravity, which is mg, cosine theta. And the x component is the opposite side to that angle, so we use sine to find the x component of gravity. So again, some component of gravity is pulling in the x direction, and some component of gravity is pulling in the y direction. That's about it, and I think that's where I'm going to leave it in terms of inclined planes in this little preview. Hopefully when we start again in the new year, we'll remember a little bit of this and it'll make some sense. Hope you have a great break, and see you in the new year.